Okay, if you need help, then just go to Desmos and take a look. Okay, huh? Okay, so I will go slowly. Let you see. 3.4, if it bothers you, you can do it last. But I think 3.4 is very hard. You can do 3.5, 3.6 first. Okay. Alex, are you done already? You done already? Okay. You done, come and get EFL 3.4. Oh, yeah. Okay. Oh. Yeah, yeah. Oh, Zoom meeting. Kang Yu is my loyal customer. And Dora, oh, two of you so nice. So now you learn fun. Okay. Okay. My Zoom meeting always says. Yeah, so that's the impressive thing. The impressive thing is that your two of y'all join without me hearing. Okay. Okay, so what? There you go. Anyone still at 3.3? David, which question are you at? 2.4. All at 3.4 already, at least. Dora, where are you at? Of the what? Yeah. I gave. Yes. You also let me or not? Okay, what? Oh. Wait, 1 second. I send you now. On your AirDrop. Oh, you have extra? Okay, okay. That's great. You should have. Okay, then. Okay, what? Wait. 5 people tell me things, I need time to remember. I got dementia already. 0.4 is 3.4, okay? You all look very bothered by 3.4. Now 3.4, if you are bothered by the first graph, okay, 1 over x, I think you know before. So then you have modulus x minus a. Modulus x minus a, I believe you know to draw as well. 1 over x, you replace y with y over a, right? This will scale it by factor a squared parallel to x-axis. If you translate by a units in the positive x term, okay? So maybe I talk about maybe graph number 1, graph number 2, graph number 3. Okay, this is just to show you intermediately what the graph is like. So this is 1 over x. Yeah, 1 over x. This is y equals 1 over x. Okay, 1 over x. Graph number 1. Okay, you'll see graph number 1. Okay. Graph number 2, no big deal. Even if I were to scale, the graph just gets steeper. That's all. The graph just gets steeper. That's all. Right? It just gets steeper. Okay. This is y, x, and y is equal to a over x squared. What I'm doing is I'm just replacing y. I'm replacing y with y over a squared. Okay, so I say again, from here to here. Okay, look at how I just copy. Okay, either stay focused. Yeah, yeah. You have to start somewhere. After which I replace x with x minus a. Right, so from here, you see what am I doing now? I replace x with x minus a. I replace x with x minus a. Okay, now, so if I replace x with x minus a, what would that be? That will be a translation in a positive, a units in a positive x direction. So what am I doing now is I'm just showing you how to draw the graph. Okay, you can use Desmos, you can listen to me, right? I'm just showing you how to do it yourself. Okay, but of course the explanation is painful, for sure, it's painful. Yeah, there are two asymptotes. When you do a horizontal translation, a units in the positive x direction, what you're gonna get something like that. Okay, you're gonna get something like that. The vertical asymptote shifts, horizontal asymptote stays. Okay, the graph now looks like this and like this. Okay, guys? Can I believe looking at this alone pumpers you, but I hope you slowly get used to it. Okay, push yourself to draw a difficult graph question. I hope you can do it. Okay, so this is the one, and it looks like that. Okay. Okay. Come again? Yes. Yeah, I'm recording. Am I recording? Oh yeah, I'm recording. Yeah. It says pause. It didn't say start. That means I've started. Okay, and okay. So now, I mean, this is also part of the recording. So I'm recording myself. Okay, so now from here, you know this graph. You know this graph. Modulus x minus I think you quite chill lah. It's just a V shape. Okay. After all that I said, if you still cannot draw the graph, okay, then don't worry. I'll show you the answer. The answer, answer looks like that. Okay. Oh, yeah. Okay, very good. Pauline, you got the graph out even before the answer shown. Okay, good. I'll show this or I'll show the second one. I show this or I show this. Okay, thank you for the enthusiastic response. Okay. Yeah, this one got wrong. I think it's 0 to A, not negative A to A. What was it that pointed out? Sound. Question 3.6, right? 3.4. So the answer is when they are equal between 0 to A. A. Okay. Can you see between 0 is for whatever you choose 3.6? Can you see? Between 0 to 3.6. So it's x between 0 to 8. Boleh ya? A is a okay lah. Y equals to x minus a. Because y equals to x minus a, but right? The graph, if you think it's a mx, you think of mx plus c, right? That means this is the intercept, then the gradient is 1. So the graph originally will look like this. Right? The graph will look like this. So here. Here, less than A or S more than equal to A. Can I? Part 4 basically is X between 0 and A. Alex, can I just check? You can get this for 3.4. Yes. Okay. Thank you, sir. Anyone at 3.5? Huh? Oh. Okay, part 3, I show you. Okay, part 3. I want to solve this, right? Okay, if you think about okay, have you drawn these two graphs? If you have. So after you have drawn these two graphs, right? Okay, this you think of it as y1. Think of this as y2. When you want y1 above y2, that means you have to look at this. Okay, let's say I color them. Okay, so Baba, you separate, I color. Okay, so I put this as brown. I put this as blue. I want brown to be above blue. I want brown to be above blue. Brown to be above blue. Brown to be above blue. So brown is my modulus straight line. Blue is my curve, right? When is my brown above blue? Is when it's at this portion, right? Where x, so actually this point is 2a lah. Where x is more than 2a. Can you see? And when is brown above blue again is when x is here, less than a. And yes, so actually this intersection point you can find by just comparing. Just calculate. You know. Now, one thing I do is, okay, if you see, okay, like how do I find it? Okay, I didn't do by this. I show you how I do, Prabha. Okay, so Prabha, I tell you, when I look at this modulus graph, right? Okay, now we know that this part is basically x minus a. This part is actually negative of x minus a. So what I do is I just equated this to this. I solve. That's the positive part, right? So I will get straight away positive part. So it helps when you break down the equation down. Get to A. Okay, then after that, question 3.5. 2.5, I think is quite okay lah, 2.5. Or is there some issue at 2.5? Anyone start? Hayden, where are you at? 3.4. 5. Challenging questions. Make sure you complete all. You want me to go to 3.3 for you? Okay, 3.3, okay. Basically is 3.3 you do slowly. Okay, do slowly. I go through the, okay, remember 3.3, right? You go through first, right? Remember 4 power x, the graph will be like this. Okay, so it's basically your right hand, this line. Hey, wow. How come? This is what this is the, when you have this line, you ask a fortune teller, means that you're very, very intelligent. Then your this line, I think is your, don't say so much. Okay, I know a little. Okay, so then if you see from here to here, right? Am I replacing x with negative x. Replacing x with negative x. Okay, so I reflect in the y-axis. When I replace x with negative x, you see, when I replace x with negative x, right, I reflect in the y-axis. Oh, here I write you very clear. You follow, let me bring you through, you should understand. Then from 4 power negative x side, I replace y with y over 2. So you see this become what happens is a scale by factor 2. Okay, so no big deal. Graph number 3, you see graph number 8. Okay. Graph number 3 is graph number 3 here. Okay, then I translate. One unit. Okay, this I go downwards. You see 1 unit, I go downwards. So this is my graph. But I'm not done yet. I'm doing graph number 5. Graph number 5, you can see this portion that is negative. I reflect. So this is my eventual graph. Okay? Is that okay? So if you can identify, what is this question trying to test me? Trying to test me how to draw an exponential graph. Oh, it's testing me a bit of curve transformation. That's how mathematics is now. Okay. Slowly. First one, inequality. Easy lah. Okay, inequality. Wait. I need to video. Okay, huh? Is this the same as this? Huh? Of course, I'm recording this. That's why I want it to be there. Is this the same as this? This is question 3.3. Same, Is it the same as this? Grandfather man. Say base is more than 1, right? If base is more than 1, the inequality is kept. Right? Therefore, okay. And so that's why if you look at question 3.3, right, you can see that the answer x is less than half. This is basically true. But because if you want this to be more than 0, right? More than 0. When you see more than 0, you just see the graph. See this graph, right? When you see more than 0, when x is less than half. Right now, x is less than half. Okay? But you can also see that the answer is over here. So Kaden, I will pause here for a while. Then, for you to absorb. If you're okay, then you do your question. Wish you all the best. Send you, oh, you're in Zoom. Yeah, okay, cool. Wait.
How do I?
Mute.
Can mute me? I can.
Okay, I mute. Okay. This is if you want to see on your iPad. Okay. So, yeah. It's a V shape, one like this, one like this. So the graph will look like this. That's very cool. Okay, so question 3.4, if you see the graph, you draw modulus and it so one looks like this, right? One will look like this. Right? What am I doing? One will look like this. One will look like this, right? Right on. So I think Sean also did something like that. So you will see that basically, right? When are they the same? Right? It's when x is between 0 and a. Okay? And x is between 0 and a. Okay, that is question 3.4. Don't worry if you don't know how to do. It's quite considered quite hard. Considered quite hard. The market rate is quite slowly, yeah. Yeah. Identical means sama. Totally the same. They're the same line. It's like if I tell you, like they're the same line. They're legit the same thing. They're the same line. Identical. Identical means, for example, y equals to x plus 3. 2y equals to 2x plus 6. Identical. Same equation. Oh. So what you realize is this line is here, right? This is the red color, right? Okay. Blue color line is this, right? X minus a. They want to show x minus a, right? X minus a looks like this. This is y equals to x minus a. Then you realize that, hey, what are you doing? How you? Don't type in the Zoom chat. Okay. Was it this class? No, it's 07. Huh? Okay. Oh, sure. Okay. Are you typing in the Zoom chat? No. Okay. Oh yeah, it's 07. Sorry. 07 delete. Okay. So what I want to say. So you can see that between these two regions, Saliha, you see carefully. From here, you can see the two lines are the same. Right? From x between 0 to a, the two graphs are the same. Okay? Can. That's what they mean by identical. It's the same. Okay. So I go to 3.5. Are you at 3.5? Okay. Are you doing well? Successful? So far, so good. Part 5 not successful. Hang you. Ask him to try to wake up if he can. Don't try to wake up. He said rest 10 minutes. So I can see it. Okay, question 3.5. So you want it to have 4 solutions. Okay, so the graph, have you drawn the graph? Does it look like this? Beautiful, right? Beautiful, just like you. So now you see, if I look at this, right? This is the original graph, right? This part I don't want. So it's going to have the whole. Sorry. Who didn't? You are. Only you? It's okay. So basically, right? Okay, when you talk about equals to part 5 equals to k, right? Same idea. You want this as one graph. You want this as another graph. Y2 equals to k, right? The solution will be the number of intersection. So I got 4 solutions. I will have 4 intersections. So I look at this graph. You see, when will I ever have 4 intersections? I just show you. Example, y equals to k looks like that. Can you see how many times will I have 4 solutions? 1, 2, 3, 4. So legit, if I'm doing like this, right? I'm taking my graph. Okay. I take my ruler, then I shift it up and down. I see how many times my ruler cut the graph. Okay? This is what I'm doing now. This is what I'm doing. Yeah, Alex, stay awake. What, you finish already? Finish already. Then do assignment. Huh? I got stuck. You got stuck. You got stuck, then you fall asleep. Do something else. Yeah. Okay. So now, history, fry or bread? Okay. Don't eat too much fried food, not good for health. Okay, so 4. Okay, see, another possibility here. 1, 2, 3, 4. So my answer is k should be between, like k must be here, k between like 0 and 2. Can you see? When k is between 0 and 2, you see, You draw. 1, 2, 3, 4. Answer. Never lie. Mr. Tan never ever tell the truth. 1, 2, 3, 4. Okay, then here 1, 2, 3, 4. Okay, so what's the answer? You can see K must be between 2 to 6. And K must also be between 0 to 2. But cannot include 2. When it's at 2, what happened? How many times? 1. Yes. I'm not showing screen, man. Huh? You mean all this time I'm not showing screen? Since the start of lesson? Huh? Past 10 minutes? Past 10 minutes I'm not showing screen? Let's go backward, then the essay is to work fast. Okay. Wow, serious? Then why nobody tell me? Why you never tell me? Huh? No. Jialat, then I record for nothing Okay. Kind of backside. Okay, so now you see okay. So one more time I say you think of this as one curve. You think of this as a second curve. Okay? Y equals to K is a horizontal line. It's a horizontal line. Okay, so cut 1, 2, 3, 4. Another case like this. Cut 1, 2, 3, 4. So that's why K means 0 to 2. K must be, but not 2. Don't include 2, don't include 0, don't include 6. It's a typo. It's a typo. Typo lah, give chance. Hey, pop type. Hey. It's a typo. Give chance Okay. Singaporean English not so good. Another make mistake. It's a typo. Okay. Maximum and minimum, I guess it should be okay for you all. 6 to 2. Since it's pivoted by 4. The rest of 3.5, I guess is okay. The rest of 3.5 I think is okay. Stay focused, don't look at other things. Okay? I think it's because I walked there just now. I walked there, there's a deep Wi-Fi spot here. Once I walk here, the internet. Okay. Yeah. So 3.4 part 3 answer is basically x less than equals to a. X less than a or x more than equal to a. X cannot be equal to a because it's an asymptote. Or if you see here, if x equals to a, what will happen? Denominator becomes 0. So when we talk about the graph, right? For this, you want to know where the graph brown is above the blue. When it's brown above the blue, modulus above, you can see when it's brown above the blue, is this portion. Can you see brown is above the blue here? Brown is above the blue here. So this point is 2a. You can solve x more than equal to a. Here, x less than a. Then you can see x is simple. Can I? Zoom out. Part 3. Okay. Part 3. Now I am at 3.4 part 3. I am at 3.4 part 3. I will just repeat whatever I was saying. Okay? When you're drawing graph, my advice is use pencil. Use pencil. Okay, I'll stop at 3.4 part 2 for a while. So far, okay, those are done go to 3.5. Last tracking was the tracking was yes, 3.55. The K, part 5, range of values for K, not for X. I say again, guys, Emily, don't look there, look there. Range of values for K, typo, question 3.5. Okay? Yeah, okay? Two first. Same thing. Same thing. Serious, got another mistake, I don't know. Same thing is the same, because a mistake or same as in got same question. Wow. Actually, I know the answer. I don't know to think. Okay, so I tell you all, okay, what's bothering you all? Don't know how to start. Will your A have two values or one value? One. Could be two, right? Could be two, right? Because your A here is set of modulus. You don't know if it's positive or negative. A could be 2 or A could be negative 2, right? So what you did is, let me check. Okay, 3, 4 can be substituted. Off your okay. 3, 4 can be substituted. Let me check. 3, 4 can be substituted inside. Well, so Okay, have you found K? You found K. You haven't found K. You found A and B, but you haven't found K. You found A. Let me sell you a story. Basically, right, if you look at a modulus function is guaranteed to be more than or equal 0, right? So AX plus B, right, is guaranteed to be more than equal 0. AX plus B negative will be guaranteed to be less than equal 0. If I add a K, right, it's guaranteed to be less than equal to K. Correct? So what am I trying to tell you? Basically, right, this guy here is the maximum value of the modulus function. What do you think K is? So K is the maximum value. Am I right to say? It's the max Y value. Or K minus A plus B. What do you think K is? What is it? Correct. Because you saw this, right? So straight away, you can say K equals to 4. Okay, after that, I start 3 and 4 inside here. Okay, you can use this to solve for A and B. Okay, so the thing is, how do I find A? Very simple. I know that picture you're telling me this A has to be the gradient of the line, right? A has to be a gradient of the line because I think these two values, y1 minus y2, y1, y2, x1, x2. I solve for this. I found that A could be -2, but then A could also be 2. Oh, right or not? Because this A here has to do with the gradient of the line, right? So A could be, K is 4, A could be 2, A could be -2. Sub these two in, I think you can find your B already now. B will be -6. If A is -2, then B will be 6. Also, that is part 1. Is that okay? Hannah? Yes. Okay. Okay, so what to say against? Okay, you look at a board.
It's a flip.
It's a flip. Yeah, it's a flip. Okay, because of negative modulus is very deep. Hannah? Okay. Hannah. So now we want to determine whether he will make a shot. Will he make a shot? He didn't. Okay, so he's trying to get into the hole. The hole is 1.5 common 1. So what is he trying to see is whether if I hit here, you know you play pool? Pool is like this. Pool. Why you rub your tongue and then you say pool? Huh? You need to go do a number 2 with it. Okay, so try to see whether you hit. Okay, you try to see whether you hit. Will it hit? You find out. Yeah. How do I know whether the modulus will cause this point? Sum in the value. Very good. Sum in the value. Oh. So after part 1, you will realize that the equation can be written as a. Okay, both ways are the same. You can either write this way. Okay. Then after part 1. So for part 2, you substitute x equals to 1.5, y equals to 1. If it satisfies the equation. If it does, it means that the equation of the line will pass through that point. It means that, makes sense, right? Okay, I mean, not assuming, just imagine if the ball to pass through the hole, the ball will not in. Okay, if it does, he makes the shot. Okay? Anyone solve this already? Would like to enlighten? Okay. You don't even know. Yeah. Huh? No. Okay, go. Okay. Where's your spec? Oh, so they go. Yeah. 3.5 part 5. Okay, 3.5 part 5, I just show you, okay, the graph, right, for it to have 4 solutions, right, you think about this as first graph, you think about this as a second graph. Okay, so 4 solution means how many times will they intersect? How many? If 4 solution means how come it? Here should be more than 0. Okay, the number of solution, right, will be the number of intersection. Right? For example, first graph y, second graph y equals something, 1 solution because 1 intersection. Now you see this graph. You see, this is the first graph, graph, right? Here. Second graph, y equals to k, right? So imagine y equals to k if it's somewhere here. Can you see I will cut 1, 2, 3, 4, 4 times? Oh, so k here, right? If it's k is between 2 to 6, I can cut 4 times. What else, Salihan? Here. If k is between 0 to 2, I can also cut 1, 2, 3, 4. 1, 2, 3, 4. I cut 4 times. So k between, so what's my answer? If k is between 0 to 2 or 2 to 6, I will cut 4 times. Y equals to k, horizontal line. Okay, this question, very popular. Very popular. I will revise this a few times. Yes, yes. The value is y. Always look at y axis. Okay, draw a graph out and then draw a graph out. Draw. Can draw now. I help you. Okay, so after you look at but the thing is, after you found A, right? A can be positive or negative. Because here this one is guaranteed to push you that A is negative, but A could be a positive value. 4 minus 2, right? 2 divided by 3 minus 4 negative. A could be 2 or negative. Correct? Because I do not know. I do not know whether this line is a big factor. Okay, A equals to correct. A can also be positive because you see x. A would be 4, A is 2, B is negative 6. Then your graph y will be equal to 4 minus 2x minus 6. Okay. Yes, correct. Or k could be 4, A could be negative 2, B equals to 6. Y equals to 4 minus modulus from negative 2 plus 6. You draw these two, you will realize that they are the same graph. Okay, that's the graph. But sub y is equal x equals to x up to b. So if x is y is equal So okay, very quickly, I just ask you. Some of you ask, for example, why is it that A could be negative or could be positive? So I just let you take a look. Okay, you see y equals to x plus 3. Here, right? Gradient is positive, right? Positive, right? Okay, so example, this y equals to x plus 3. Look here. Let's look here. Here, Sean. Look here, look here. Okay. Joshua, look here. All eyes on me. Yeah. Okay, so I must show your cube. Okay, where's the picture? Cannot show the picture. No, never mind. Okay. So you see y equals to x plus 3. So you all look, if I do a modulus, what will happen? This one reflected out, right? If I do a negative x minus 3, if I do a modulus, what happens? Yes, it's the same graph. You understand? It's the same graph. Okay, that is why A here could be 2 positive. That's why A here could be 2 positive values. Like two values. Okay, A could be 2 minus 6, or A could be negative 2 and 6. There are 2 possibilities. Okay, ma? Can anyone want me? I can repeat again. More than happy to repeat a few times. Okay, so I'm going to repeat again because I'm sure some of you were not in this question yet when I went through just now. Now, first, how do I find K? K is the maximum Y value. Emily, strong, K. K is the maximum Y value. But because this graph, if I know that AX plus T is always going to be more than equal 0, then negative AX plus B is always going to be less than equal 0. So if I add a K, right, a negative modulus added with K, the maximum is going to be K. And what is K here? You see, right, this graph, what is K going to be? The maximum Y value is 4. That's why K is equal to 4. Okay or not? Okay, just by observation, K is equal to 4. Then if, so what else? How do I find A? Now A here has to do with gradient. If I look at this line, because this graph could either be, two versions. It could be y equals to k minus ax plus b, or it could be y equals to k plus ax plus b. Either way, you can see that a is the gradient of the line. Okay, which is why if I find, looking at the screen, if I do a shadow, y1, x1, x2, y2, right? Just take y2 minus y1, x2 minus x1. I can find the gradient of the line. Okay, which gives me a equals to 2, a equals to negative 2. Then finally, I'll submit to find b. Is that okay? Yeah. So I determine. So determine whether he will make the shot. Did he make the shot yet? Huh? He made the shot? Correct! Sadhana is the first person to answer it. Well done. He made the shot. Because when you submit, you found that equation. Okay, he fulfills the equation. So he made the shot, guys. Jack did make the shot. Jack. I still see him every Tuesday. You know, not every Tuesday, I bring my son for swimming at Delta. He's still there. Now, compare already lah. Now like yours, compare. It's not purple. This is not purple. Yours is not purple. Yours is purple. That was a quick one. But I think he firm, right? Okay, so now there's a pole lying on the golf green. The pole can be described by y equals to mx plus 4. This is the pole, right? Right. So you know how those who play golf, you know something, you put a pole there to guide you to the pole. Okay. It can be rotated by a pivot at 0.4. It means that I'm doing this, the curve. It means that coming soon. It means that it can be pivoted about 0.4. It means I'm doing this. Okay, this one can pivot. How can pivot? Now, 0.4, there's a point here, there's a pivoting point. It can be like this, you can move from here and here. Okay, I hit a golf ball at 3.5, 1 here. Geo hit the ball. Oh, Jack and this one. I move it this way. In the case where m equals to -1, find the coordinate at which the golf ball hits the pole. Okay, so I'm trying to mimic this equation. This equation, the one in blue is going to hit the one in brown. Are you able to do it? No. Okay. So very simple. The one in blue and the one in brown. In the case where m is -1, y equals to -x plus 4. That's equation 1. Y equals to 4 minus 3x minus 7.5. Equation 2. Just solve simultaneously. Should be easy lah. Okay or not? But if that bothers you, may I ask? Okay. You are doing now, okay. So what I want to say is, this portion of the graph, when it hits, right, is actually y equals to 4 minus, meaning the negative of 3x minus 7.5. Y, correct? That's the first question. Y, right? Y. Okay, so it's because of my okay. When I'm talking about y equals to y, okay, let's say I talk about y equals to 4x, 4 minus 3x minus 7.5. Okay. What could this be? Okay, so if I talk about 3 modulus of 3x minus 7.5, it could either be 3x minus 7.5 or 7.5 minus 3x. This is when x is more than 2.5. This is when x is less than 2.5. Okay, you all follow me so far? No. Okay, I'll say again. Here, I'm going to unpack for you the equation of this arrow here. Now, what I want to redo is I want to remove the modulus. Okay, I want to remove the modulus. So the modulus here, this is the point, basically 4, okay, 2.5, 4. Okay. Now, when I look at a modulus, you go back to definition. When is the modulus of fx going to be? Modulus of fx could either be fx or the negative of fx. Am I right? When x is more than 0. Okay. So here you can see that this y value can either be itself when x is more than 2.5, or it can be the negative of itself when x is less than 2.5. Hey, Xavier, stop closing your eyes. You blindfold you already. Okay. So 3x minus 7.5 more than 0, right? 3x more than 7.5, x plus 2.25. Is it okay? So that's why y equals to 4 minus 3x minus 7.5 is equals to 4 subtract 7.5 minus 3x when the ball hits the pole, which is 3x minus 3.5. Is that okay? This one is very difficult. So I'm trying to go very slow. Let's see if you all understand. Only if you follow me from the start, then you will understand. If you join halfway, you will be lost. So I say again, I unpack for you what is the modulus function. It could either be itself or the negative of itself. But if I look at this graph, you can see that at the point where it touches the pole, it's actually the modulus is the negative of itself. It's actually negative fx that we are talking about. That's why I'm trying to tell you that at this point, we are looking at y equals to 4 subtract negative of 3x minus 7.5. Okay? That's what I'm trying to tell you. At this point, I'm trying to tell you this equation of this line. So that you don't have to deal with the modulus. Because the modulus will kill you now. Is that okay? Not okay? Okay, not okay. Not okay, don't worry, just say yes. I'm willing to say the same thing 10 times. That's why I'm a teacher. Yeah. Yeah. Why is it negative? Okay, so maybe I draw the box. Yeah. If you look at the modulus, right? Remember the modulus function? Y is okay, remember modulus fx. It can either be itself or the negative of itself. Okay, cannot. I'll go to the definition. So if I look at this 3x minus 7.5, it can either be 3x minus 7.5 or negative of 3x minus 7.5. Fair? When is it going to be? See, when fx is more than 0 lah. That means I want this to be more than 0, right? Okay, 7.5 divided by 3. I do some speedy math. This means that I will need x to be more than 2.5. Here, I'll just take a complement. If I'm not more, let's start. X less than 2.5. Can I say that? Now, here, this part, if I look at the graph, you can see x is less than 2.5. Oh, so this equation, right? At the point where ball hits pole, when the golf ball hits the pole, your y equals to 4 minus modulus 3x minus 7.5 is equal to 4 minus, is equal to this scenario. Equal to this scenario. Because, can you see, at this point, my x is less than 2.5. Or my x is basically negative 3x minus 7.5. Which is 3x minus 3.5. Okay, I'm trying to unpack this into this so that easy for you to solve. Is there anyone who need me to repeat again? Don't worry. You can just tell me. 4, 7, I repeated 6, 7 times. Yeah. May not be. So you must unpack. The negative. Oh, okay, for this one, you can see that. Okay, so next one. Okay, so I go on. I don't want to just show you the answer. Because I show you the answer, you don't learn anything. Okay, I want you all to see. Okay, so this is the first graph, the pole. This is the Emily. Look here, not looking outside. So this is the second graph. Okay, this is the movement of the ball. This is the golf ball. The golf ball is moving this direction. This is the golf ball. This is the pole. Okay. Okay. So now I go to part 2. Please try your best to understand. Okay, or fry your brain cells a bit. I know it's not easy, but trust me, the best time to understand the question is now. Yeah, there's no other time. When I was a student, I always tell myself, I go back home, then I try to figure out. It's too late. It's too late. Okay, you'll spend a lot. It's very difficult. You can't figure out. Don't you and Kaden use the same strategy. So what's the deal about the two hands? Show me your hands. Show me your hands. Show me your hand. Show me. Isabella, show me your hand. Are y'all drawing on each other's hands? Wow, y'all too. So something fishy must be going on. So I'm gonna send this video to your parents. Okay, kidding. So now we talk about part 2, is it? Part 2? Now part 2, right, I want to rotate at the case where it does not hit. Okay. So you see, the 4 minus 1. Okay, I want to such that it does not obstruct the golf ball from the pole. Find the range of values of x. Okay. So basically, right, what you want is you see, okay, if I look at part B, you're still listening. I feel like quite lonely. Are you still listening? You are okay. Sure. Okay. Now you must use common sense. This will go this way. You want it to go this way, and you want it to go inside the pole. That means, right, where must my pole be? My pole must be here. It must be here. So my pole, right? If I'm gonna, what I want is I want my ball to reach this part. That means my pole has to be behind. Yes, behind the pole. It cannot be on the hole or in front of the hole. If it's in front, it's going to be blocking. So it has to be behind. Now, if I look at these 2 points, right? Can you tell me the gradient of these 2 points? This 4 minus 1, 0 minus 1.5. Okay, so I look at these 2. You can see, what's the gradient? The gradient is negative 2. Negative 2. Okay, negative 2. Okay, if I look at this line here, I just show you over here. This pole, the red line gradient is negative 2. Basically, what must I do? I must make sure, okay, this one is fixed. I'm pivoting around this point, so I cannot. But I want to tell myself, I want to make sure that I am going to shift back. That means, what must my gradient be? Lower than negative. Or because you see it like that, right? What's the gradient that is? Maybe negative 3. Steeper, right? Steeper. It must be less than minus 2. Then the ball can go to the hole. Okay? And yeah. So that is the question. Yeah. So if you have finished everything, then you show me. If you haven't finished everything, you cannot leave the class. Yeah. You finished already. Okay, then you can do a AFM. Done. Huh? Which one? No, now. Try your feet. Okay. Let me give up the air. Alex and yeah. Big question. 3.14. 3.44. 3.44. Just nice. Sadhana also need the question. Okay, 3.44. Basically, right, this question. Okay, A minus X will look like this. You managed to draw? Okay, then modulus X minus A will look like this. Okay, then this region here, right, you can see where they are identical, right, is where X is between 0 to A. Okay, ma? Yes. Zero to A. 0 to A. Yeah, that's the answer. Oh, now?
Does anyone have an extra AFL?
Don't have. Who don't have? How many don't have?
One person.
One person. One person.
Yeah.
This one, I don't know why every time like we give our is always short.
Yeah. I think because I think 28. You have 29.
Who don't have? Who don't have? Yeah, happy.
Maybe I give him kids.
I need to give Ashni a topic for AFL also. Only AFL one. Isabella one calculator. Only Prabha has. So tomorrow, okay, can I just check?